China just became the first nation in history to collect samples from the far side of the moon, a place we've never touched before. Hidden in a 500-kilometer-wide crater, this region may hold frozen water and ancient materials older than Earth itself. If confirmed, it could change everything, from how we power lunar bases to how we understand our solar system. But here's the twist: this breakthrough could also ignite a new space race, and some experts say the stakes have never been higher. China's lunar program stands at the crossroads of science, technology, and geopolitics. Over the last decade, China has methodically advanced its Chang'e program from initial landings to far-side exploration and sample returns, marking a rapid transformation from newcomer to lunar powerhouse. These missions are not abstract experiments. They are tactical moves aimed at securing a strategic foothold in space. Globally, lunar exploration has shifted from symbolic achievements to practical competition. Countries now recognize the moon's untapped resources, especially water ice at the poles, as essential for sustained presence and fueling further space missions. China is targeting the lunar South Pole, a region of permanent shadows where ice deposits might be mined for life support and rocket fuel, making it a coveted prize in the new space race. China's ambitions extend beyond robotic missions. The Chang'e program is a carefully orchestrated pathway toward establishing an international lunar research station, collaborating with allies while simultaneously pushing technological independence. With rival programs like NASA's Artemis targeting the same polar regions for human landings, the moon has become a new frontier of geopolitical stakes and power projection. The significance of China's lunar ambitions is clear. This is a race not just for exploration, but for influence over the next era of humanity's expansion beyond Earth. Success in these missions will shape scientific knowledge, control over space resources, and global security dynamics for decades to come. Understanding this context is crucial to grasping why China's moon missions are essential knowledge today, signaling a profound shift in how the world engages with our celestial neighbor. In May 2024, China launched Chang'e 6 on a Long March 5 rocket from Hainan Island, aiming to do what no country had achieved before: collect and return lunar samples from the moon's far side. This remote, hidden lunar hemisphere had always been a mystery, shielded from Earth by the moon's synchronous rotation, making communication and navigation an unprecedented challenge. The mission's trajectory was a masterpiece of precision. After entering lunar orbit, the lander carefully descended into the South Pole Aitken Basin, a colossal, ancient impact crater believed to hold clues about the moon's origins and early solar system history. Using advanced autonomous systems, Chang'e 6 performed a delicate, low-altitude hover and executed a soft landing on the uneven lunar surface, marking a legendary milestone in robotics and space engineering. Over the next 2 days, the lander's robotic arm drilled into the lunar regolith and subsurface rock, collecting pristine samples unlike any previously retrieved. For the first time in human history, material from the far side was gathered, shedding light on the moon's composition and history outside the range of past missions. Then came the intricate ascent phase, a small vehicle lifting off from the lunar surface and docking with the orbiter. This required flawless timing and coordination billions of kilometers away, demonstrating China's growing mastery of complex space maneuvers. Once securely docked, the samples were housed carefully for the long journey back home. The mission's success was not only a triumph of science, but a geopolitical statement. While international collaboration played a role through relay satellites to enable communication with the far side, the mission was primarily a demonstration of China's independent capabilities in space exploration. Chang'e 6's remarkable blend of advanced technologies, hover phases to navigate difficult terrain, 3D lunar mapping to guide autonomous landing and sample collection, and automated docking techniques, showcases a leap forward in lunar exploration. This mission rewrote the record books and set the stage for China's expanding ambitions on the moon, capturing imaginations and raising questions. Why target the far side? What secrets remain buried in that ancient landscape? It's clear. Chang'e 6 changed everything by turning a once mythical, unreachable region into tangible human achievement and knowledge, forging a new chapter for lunar science and space power. The Chang'e 6 mission returned with samples from the Apollo Basin, the largest and oldest known impact crater on the moon's far side, a geological treasure trove holding clues to the moon's earliest history and the dynamics that shaped our solar system. Scientists around the world eagerly await these rocks and soil, hoping they will unlock answers to persistent mysteries. How was the moon formed? Why does the far side differ so much from the near side? One of the most tantalizing hopes is to detect water or its chemical signatures in the samples. Water on the moon isn't just a curiosity, it's a potential game changer. Trapped as ice in permanently shadowed craters, this water could be mined to support life, produce fuel via electrolysis, and enable sustained human presence without constant resupply from Earth. The presence of water ice would mark the moon's transition from a barren science experiment to a vital stepping stone for deep space exploration, enabling everything from lunar bases to Mars missions. But this water also raises geopolitical questions. Limited access to such resources will create competition and new conflicts over lunar territory. Chang'e 6's samples are therefore both scientific and strategic. They help answer humanity's fundamental origins while setting the stage for who will control the moon's future. It's a moment of discovery on the edge of a new era, where lunar ice might fuel not only rockets, but also the ambitions of nations. As we await deeper analyses, one thing is clear. What was found on the far side could power humanity's survival off Earth and shift the balance of power here at home. This isn't just data, it's the foundation for a new chapter in space and politics. China's lunar ambitions do not stop with Chang'e 6. The missions Chang'e 7 and Chang'e 8 are the next deliberate steps in a carefully planned roadmap toward establishing a permanent, sustainable presence on the moon. Chang'e 7, slated for launch around 2026, is designed to target the lunar South Pole's Shackleton crater, a region of intense scientific interest. This area receives near-constant sunlight on its rims, while its deep shadows harbor deposits of water ice. The mission will deploy a suite of advanced instruments, including orbiters, landers, rovers, and even hopping probes to explore these harsh terrains. Its goal is to confirm water ice quantities and distribution, critical for future lunar habitats and fuel production. Next comes Chang'e 8, an even more ambitious mission set to demonstrate technologies for living off the moon's resources. It will test 3D printing techniques to create structures using lunar soil, effectively pioneering building methods for future bases. Chang'e 8 will also check the feasibility of sustaining long-term robotic and human operations, including energy generation, waste recycling, and habitat construction. These missions are the build-up to China's bold plan for the International Lunar Research Station, EARS, a collaborative project involving Russia and potentially other nations. EARS aims to serve as the first step of a continually inhabited lunar base, aiding scientific research and training for Mars expeditions. But this progress is part of a larger, high-stakes contest. NASA's Artemis program also targets the same polar regions, with plans for human landings and permanent bases. The Shackleton crater in particular is a prize contested quietly but fiercely by competing space powers. This hidden race is about more than prestige. It's about control over resources, territory, and future pathways for human exploration. The Moon is becoming a geopolitical chessboard, where robotic probes and human missions advance complex strategic goals. It is a story of technology pushing forward on one side and global competition tightening on the other. A delicate dance that will shape the trajectory of space exploration for decades to come. Human spaceflight marks the ultimate test of any nation's lunar ambitions, and China is preparing to take that test, and likely pass it, with the launch of its most advanced crewed missions to the Moon. Central to these efforts is the Long March 10 rocket, a massive new heavy-lift launch vehicle designed specifically to carry astronauts and equipment beyond low Earth orbit. This rocket symbolizes China's readiness to challenge the dominance of historical spacefaring nations and claim its place as a leader in deep space exploration. Alongside this rocket, China is developing the Mengzhou crew spacecraft, which will ferry astronauts from Earth to a lunar orbiting station where it will dock with the Lanyu lunar lander. The complexity of docking spacecraft in lunar orbit and then landing safely on the Moon's surface requires advanced autonomous control systems and rigorous testing, and China has steadily made progress through successive unmanned missions. China has set the ambitious target of sending humans to the Moon's surface by 2030, marking a historic milestone. But unlike the Apollo missions of the 20th century, which were brief visits, these missions aim for prolonged human presence, building the foundation for permanent lunar bases. The International Lunar Research Station, ILRS, a joint effort with Russia and possibly other partners, is envisioned as a lunar outpost supporting scientific research, training for Mars missions, and long-term habitation. This race to human landings is happening alongside NASA's Artemis program, which has its own schedule and goals for landing astronauts and sustaining operations on the Moon. Both agencies target Earth's South Pole region, where water ice and near-constant sunlight could enable life support and fuel production. This overlap has fueled a quiet but intense geopolitical competition, as nations seek to establish operational and territorial precedents on critical sites. The stakes couldn't be higher. Whoever lands first, and who builds the infrastructure to stay, will control the Moon's gateways to the rest of the solar system. This is not mere national pride. It's about access to resources, new economic frontiers, and strategic security. Furthermore, the successes of these crewed missions could redefine humanity's future, not only making us a multi-planetary species, but also shifting the balance of power on Earth. The technological, political, and cultural implications are profound, and perhaps the most consequential space endeavor since Apollo. Ultimately, this is a race not just of rockets and astronauts, but of vision, will, and long-term strategy. The Moon is no longer a symbolic goal. It's the launching pad for humanity's next giant leap, and the question remains: who will set foot first, and what legacy will they leave behind? The Moon is more than a celestial neighbor. It's the keystone in humanity's quest to expand beyond Earth. China's lunar program is a clear statement that the Moon is no longer just a distant dream. It is now a strategic platform for future exploration, economic opportunity, and geopolitical influence. Long-term plans include constructing lunar bases capable of continuous human habitation, designed to support scientific experiments, resource extraction, and even industrial activities. The lunar soil itself will be repurposed, with technologies like 3D printing to build habitats and infrastructure without launching everything from Earth. Water ice will be harvested for fuel and life support, making the Moon a refueling station for deeper space missions. Communication networks are another critical piece. Establishing a robust lunar satellite system will allow near real-time communication across the Moon's surface and back to Earth, enabling coordination of robotic and human activities and supporting commercial and scientific endeavors. But the Moon's true role is as a gateway. It's the logical first step in humanity's expansion into Mars and beyond. With lower gravitational pull than Earth, launching missions from the Moon is far more efficient, reducing costs and hurdles for interplanetary travel. China's vision includes using the Moon as a staging ground for Mars missions and other deep space exploration. Yet, these opportunities come with profound challenges. The Moon, once seen as a shared heritage of mankind, is fast becoming a contest for resources, territory, and control in space. The infrastructures built there will shape who holds power in the coming centuries, whether it is shared cooperation or competitive isolation. This new space era carries echoes of past earthly frontiers, full of hope, peril, promises, and risks. The Moon may be just the beginning, but what humanity chooses to do there will define our role in the cosmos. So, as China extends its reach across the lunar surface, the question stands for all of us. What role will humanity play in this next era of space? Will we come together as explorers and collaborators, or fracture under the pressures of competition and conflict? The Moon no longer belongs only to astronauts or scientists. It belongs to every one of us who dares to imagine the future. The end game is not the Moon itself, but the destiny it unlocks. This is the grand vision and sober reality behind China's lunar ambitions. Spaces of awe and ambition intertwined with great geopolitical consequence. We've just unpacked China's ambitious and intricate plan for the Moon, from pioneering robotic missions harvesting ancient lunar soils to forging the path for the first sustained human presence off Earth. This is a story of science, strategy, and silent competition that will shape not only space but our planet's future. If intelligent, deep-dive space breakdowns like this captivate you, you know what to do. Subscribe and join a community of thinkers who want to stay ahead of the curve in humanity's greatest adventure. Because understanding the Moon's evolving story means understanding our own. Space is no longer far away or out of reach. It's here, it's urgent, and it's ours to watch closely. Stay curious, stay informed, and stay tuned.